We're now going to have a look at user-defined types, or for short, UDTs. These play quite an important role in the Siemens environment, especially when we start looking at version control, library management, reusability of systems. And what they are effectively is, just like function blocks are a blueprint for interfaces, UDTs are blueprints for data. And effectively, like we have booleans, integers, reals, a UDT is its own data type, and you can define what sits within that data type, including the basics like bool, int, and real, but also other UDTs that you define. So you can have big architectural and hierarchical systems where UDTs rely upon other UDTs, and when you update the sort of base layers, anything that is dependent upon the UDTs that you're editing, they also receive the update. So right now, right at a basic level, they might not seem that important, but when you get into large scale projects or things that need to provide easy ways to be scalable, UDTs are really important. So the first thing to note is that UDTs are not found in the program blocks because they don't have any relevance to holding data or any logical output or process. They are literally templates. So they're found in their own thing called PLC data types. And in here you have system data types, which right now we're not making use of. Things that are bought in by hardware that you're using or specific GSD files and things like that might populate the system data types with information. And here we have add new data type. So if I give that a double click, it literally opens what appears to be a data block, but you can see that there's no static, there's no sort of scope to the data, no input, output, or anything like that. It's just a table. And in the table, we can type our variables. So I can go enable results, and I'm going to put the structure in here as well for test, make it a struct, and then R1, R2, R3. So this is similar to the structure that we saw in a previous lesson. I'll set these to real. So here I have the same setup that we had in the data block. I've just fixed the naming of this and this, but essentially, let me just change that to real. Essentially, we have the same thing. And you'll notice that we have nearly all of the same options that we have for a data block. So default value, accessibility, set point, but we don't have the ability to say retain the data because we're not in a sort of environment at a data type level where we can retain anything. That this can't exist on its own in the PLC. A UDT must be something that is used to define a data block or a variable. So let's give it a name. We're going to call this our test. In fact, actually, good naming convention sort of habit to get into here is I always prefix UDTs with UDT. It makes it really easy to know whether you've created the UDT or whether it's something that was given to you by Siemens or by some particular vendor that you have installed from a third party. Typically, I've never seen anything other than what I've created or prefixed with UDT. So we'll call this UDT test system. And now when I go to program blocks and add new block, I'm able to come to data block, and in my list here, I have UDT test system. So I'm going to call this test system 1, click OK. And you can see that it's given us pretty much exactly what we had in our global data block. Let's have a look at test here. Okay, so we added test array in our previous lesson, but if I put them side by side, we have enable, target, results. And if I open results, we can see that we have the same system. Now, because everything is named symbolically, if we were to delete test and change our test system to test, all of our references should match. So the way that this data is used is not different, but it is tied explicitly to a blueprint. So for example, if I come into UDT test system, let me just swap these windows around. So here I have my UDT on the right-hand side, and I have our test DB or test system DB on the left-hand side. And remember that this window here, or this DB here, is referencing this UDT. So if I go ahead and add a R4, you see that we get an X here on the left-hand side immediately saying that something's wrong. This test system DB does not match the UDT it's associated with anymore. And I can right click and go to update interface, and now R4 appears. And whilst that might seem sort of tedious, or what's the point in defining this like this way, I could have just added R4 into my global data block. It becomes much more apparent when you start using this or using UDTs with function blocks. For example, if I create a new function block now, and we'll call this our UDT interface block, click OK, I can now give it a single reference. Let me turn the split screen off. I can give it a single reference, so input, for example, and I'll call it test structure UDT test system. In fact, I'll call that test system. That would make more sense. And in here, through a single variable, we've now defined everything, including the new R4. If this was all put out as individual inputs, not only would our interface be much bigger in terms of physically on the screen, but if I changed anything in UDT system or in the data block, this wouldn't be updated either. So we'd have to come here and also add an additional input in order to capture that information. If I come into main and I drop an instance of this, this new block, let's just delete that. So UDT interface block, let's create the instance data with it. So now I can drag in my test system 1 and just put it on the front of the interface here. And if I hover over the input, we can see that it's a UDT test system. That's what the input expects. And if I hover over what I'm passing, which is the entirety of DB4, so the whole data block is being passed in, but the whole data block has the type UDT test system. So we are passing the correct information. If I come into my data block, my function block, sorry, and have a look, we're passing in everything that's needed, including the new R4. And then let's go ahead and have a look at what happens if I change the UDT test system. So before we make any changes, let's just have a quick look at what we're expecting to happen. If I come into the UDT interface block, typically, if you're not using UDTs and you wanted to add information into the system, we would be right-clicking, add row, and perhaps putting, result 5 and setting that as a real. And we might need to do this 6 or 7 times, depending on how many new results we wanted to bring into this function block. However, with a UDT, we would be able to come to sort of this result here and say, let's make this an array 0 to 99 of struct. And this will go ahead and update the variable result to now include 99 instances of R1 to R4. So we can see that we have lots of these here. If you wanted to do this to that function block, you wouldn't be able to add this many interface inputs. Pretty sure you're limited to 100. You can only have 100 inputs to a function block. So if we go and have a look at how this function block looks now, we can see that we have this UDT test system in red. I'm just going to delete that one. If you right click and go to update interface, it's now re-pulled the UDT and updated what test system has access to. And if I open this, we can now see that we have all of these results available inside this structure. And if I go to main, where we're calling this, you can see that the function block is complaining that it needs to be updated. Right click, update block call, click OK. And although the function block has been updated, so the instance data within the function block, it's still complaining that test system 1 needs to be updated. And in here, right click, update interface, and that's updated as well. Now that sounds really long-winded, but you can just click program blocks and then click compile, and that will do everything that I've just done. But I wanted to show you exactly what changes, because it is important to understand what you're doing. So again, UDTs are, I would put them at the sort of beginning of the intermediate level, but they are really, really important for scaling systems, for modular usage, and also if you want to make use of version control, they are necessary. So it's important to understand their impact on large projects. But that pretty much sort of governs all of our building blocks that we need. We now have all of the programming blocks, OB, functions, function blocks, data blocks. We know the difference between global data and instance data. And we also now have an understanding of user-defined types. So in the next section, we will be looking at programming languages and starting to put some logic together that looks at this data.